I have a factorable trinomial in here, but it's kind of hidden a little bit. So we need to be a little bit clever, or a little bit clever. We need to be clever in how to figure out how do we start. Because I noticed that my leading coefficient isn't a 1. One observation. What's the other observation that you might have? Every one of these terms has something in it that I can already pre-factor out, or I can do an initial factor. Each of those terms has a 3 and an x as its greatest common factor. So I can factor out a 3x, and then I'm left with an x squared minus a 5x minus a 14. Just checking if I did my work right. 3 times 14 is 42. So I factored. But like every time that we factor, we just keep factoring until there's no more to factor. Well, 3x I can't factor anymore, but I have a trinomial, and it looks like it very well can be factorable. So let's go ahead and continue or work into our process here with the one addition. I'm going to carry this 3x with me everywhere I go, because that was part of the original problem. So here's my two parentheses. Notice it's really the same. Now it's the same. Now it's just with the 3x tagged along because that was part of it. I can put x's in those first two spaces. No difference here. Look for all the factors that make a negative 14. Negative 7, a positive 2, 2 and a negative 7, 14 and negative 1, negative 14 and a positive 1. Did I miss any? I do not believe I missed any. Out of those four possibilities, which one produces a negative 5x? So I can put a negative 7 and a positive 2. And that trinomial now has been factored completely. And this time, I'm left with three factors. One factor is a 3x. One factor is an x minus a 7. Another factor is an x plus 2. And I can't factor any of those any further. So I am done with that problem.